covalent bond in hydrogen chloride HCl molecule. We will explore the formation of covalent bond in hydrogen chloride molecule, or we can refer to it as HCl. It's composed of one hydrogen atom H and one chlorine atom Cl. So this is the hydrogen atom, and as you see, it has one electron. This is the chlorine atom, and it has 17 electrons distributed over 3 energy levels. There are 2 electrons in the first energy level, 8 electrons in the second energy level, and 7 electrons in the third energy level. Notice that the electrons are distributed in pairs, so 2 electrons, except 1 electron in the outermost shell. And this electron will seek to pair. Hydrogen and chlorine will form a covalent bond, since hydrogen needs 1 more electron to make a pair of electrons, and the same for chlorine as well. Therefore, chlorine and hydrogen will share electrons, attraction will occur between the 2 atoms, and they will share a pair of electrons. As you see, there is 1 electron from hydrogen and 1 electron from chlorine. This pair of electrons form the covalent bond between hydrogen and chlorine. They now both have a pair of electrons, and this model shows the covalent bond. In this model, the covalent bond is represented as a dash between hydrogen and chlorine. It represents a pair of electrons. In this simulation, what we need to focus on are the outermost energy levels because they contain the lone electrons. Attraction occurs between H and Cl, and sharing of electrons takes place, forming a covalent bond, and therefore the HCl hydrogen chloride molecule. As you see, the covalent bond is represented as a dash, and it refers to pair of electrons.